everybody, so I want to do a quick video recap of some of the notation that comes into play, both in part 6 and part 7, because it is kind of nuanced and definitely a place where students make mistakes. So first and foremost, we use different notation and statistics for values that come from a sample and values that come from a population. So I'll start out by just writing population. Oh, yes, that's how you spell population. And sample. My face is in the way. Won't move me down. Now, there are some keywords that can make sure it's obvious if we're dealing with something from a sample or a population. I'll give you those before we move into the notation. Technically, with population, we might see words like true or actual. Those are good ways to let us know that we're dealing with the real value. With sample, we might see things like survey or estimate, because we use the sample data to infer, right, things about our population. We'll try to make a conclusion that direction where our sample is technically or should be a subset of our population. Now that we've recognized which one is which, we also have some other keywords that can give us some indication. What we see as we transition from 6.1 to 6.2 is in 6.1 we're dealing with, we know the true population proportion, and let's figure out the chance of getting a sample that looks like the one we got. In 6.2 we transition and we go to say, okay, well, we don't really know the population proportion. In a lot of situations that's impossible to know, so how exactly would we guess at what that is using the sample? We move to inferential statistics from our sampling distributions. So as we make that sort of change, you may see words like assume or suppose. And these are words that are basically just letting you know it's not necessarily the true value, but because we want to do some problem that we have no way to do otherwise, we're going to assume that 25% of the candies are actually pink, and then we'll move forward with what we're doing. So once we've made our decision whether we're in a population or a sample, there are two different things that we're going to be dealing with, right? Well, a number of different things. But for part 6, we're in this land of proportions. Proportions are also probabilities, technically. They're also percents, but we're going to use the word proportion. That's typically used. These are a way to summarize categorical data. So behind the scenes, there's a categorical variable that has a yes or a no, and we're looking at the proportion of yeses. And if you want to bring that back to our binomial experiment, it's the probability of success, right? The chance of getting a success. So if we're in proportion land, then what we're looking at here, a population proportion is equal to P. This is our population proportion or probability or percent of yes, of whatever we're counting, of our successes. If we're in sample land, we throw a hat on this to let everybody know it's not the real deal, it's a guess at the real deal, and this is our sample proportion. I do know that there are people, I really respect Alan Rossman. He's an amazing stats professor over at Cal Poly. And this is one time, proportion land is the one time that we break the rule you see everywhere else. When we get to part 7, you'll realize eventually, and I'll go ahead and just tell you now, when you get to part 7, we also have means and standard deviations that we can talk about in both a population and a sample land, in both a parameter and a statistic, if you remember the terms we used back in part 1. And when we talk about a population mean, we use mu. When we talk about a sample mean, we use x bar. And then we also have standard deviations. Ooh, I wanted black. Our standard deviations. For standard deviations, now we use a sigma and an S. So what Alan says is typically we use Greek letters when we're talking about population values, these unknown things in inferential statistics, and we use what we typically think as traditional, right, letters in English for our statistics. So he actually says that you should be using pi here, as your Greek letter for the proportions. That way we're kind of sticking with Greek for our parameters or our population values. One other thing I want to talk about here, I'm going to give you a little brief debrief of 6.1, but as you move into part 7, I've had students already ask me if exam 3 is going to be broken into 2 pieces, just like exam 2 was. The answer is no. For exam 2, the 2 sections were really compartmentalized, very different. Having them together just seemed unnecessary. But for exam 3, telling the difference between the situations of part 6 in proportions and part 7 in means is an important distinction to be able to make as a statistician. So I want to make sure that you guys can do that. For means, instead of dealing with categorical data that takes a yes or a no, we're dealing with numeric or quantitative data. So in this case, the only way to summarize a bunch of numbers, or one of the ways to summarize a bunch of numbers, is with their average or their mean. Standard deviations are also a way to measure our quantitative data, right? It gives us the spread as well as the center. Whereas for a categorical data, a proportion alone tells us both where it was centered, what the most likely outcome was, and how spread out it was. Because technically, the further it is from 50, the more spread out our data was, the more variability there was. Or the closer it is to 50, sorry, the more variability there is. Took me a second there. Just as a indication, this would be less variable than this. And that's always contrary to what students would think, but we have more stuff clustered at the same value in the first drawing than in the second. There's definitely more variability there. So moving on to a quick debrief of sampling distributions and what you saw in 6.1. I do want to do that. So sampling distribution-wise, the goal here is to think about really the dot plots that you guys saw on the smelling Parkinson's activity. I can't remember if I put one in the confidence interval activity. It's been a while since I did that one. And also the dot plot that you will see in the Beyonce activity. So there's a bunch of plots that you see that basically show you sampling distributions. A sampling distribution tells us what would happen if we took a lot of samples, all of the possible samples actually, and graphed them. So what will happen, and we'll talk about the notation here as well, we'll just deal with 6.1 for a second. In terms of 6.1, if you were to take a bunch of samples and figure out the proportion of times that you guessed the right number of t-shirts, or the proportion of times that a Hershey Kiss landed on its base, all of these things have categorical yes-no data, what should happen is what you should see is eventually what starts to look like a normal distribution. And this approximate normal distribution will be centered at the real proportion of kisses landing on its face or shirts guessed correctly or whatever the heck we might be talking about, with a standard deviation that is the square root of PQ over N. So when we look at something like this little subscript of this P hat, this says the mean of all sample proportions. Oops. And this says the standard deviation of all sample proportions. And so we have some formulas that help us out with this, our P and our square root of PQ over N. And this lets us look at a particular sample to see if it's unusual, or a particular sample to see what the probability of getting that is. So a lot of you guys missed points on number 6 and the last knowledge check. I can't remember what it was, knowledge check 10. I guess. And the bigger issue here was that we didn't recognize, it said assume 25% of the candies are pink. Assume this is correct. That was telling you the real P, the real proportion of pink candies in a bag was 25%. And then it asked, well, what's the probability, if that's true, of getting out 30% of the candies being pink in a particular sample? And they went on to say we're going to sample 300, so they told us our N. And then they said, what is the probability of getting out a proportion in that sample, I think that was greater than 30%. So you could have done that, found this proportion using the mean and standard deviation in green. Of course, in this case, they'd be 0.25, and then whatever the heck the square root of 0.25 times 0.75 divided by 300 is. A lot of you use 0.3 here, not realizing the difference, again, going back to the beginning here, of our p versus our p hat, and reading really carefully for those keywords, which is going to become crucial in 6.4 or whatever the heck I named the hypothesis testing section. You also could have done this by figuring out the probability that our number of pink candies was greater than 90. In this case, I think it might have been greater than, I don't remember, it doesn't matter. And you could have done that either using the normal approximation to the binomial or the binomial calculator. So either one would have given you a correct answer. So that was technically the 3 answers I was looking for. Using a binomial with these parameters, using the approximate normal to a binomial with the mean of 75 and a standard deviation of whatever the heck was right above it. I think it was like 7.5. Or using the normal approximation for a sample proportion, using the sampling distribution of a sample proportion where your mean was 0.25 and your standard deviation was the square root of 0.25 times 0.75 divided by 300. Anyways, hopefully that helps a little bit. I know it was a really quick sort of like, here's some of the stuff, but I do think that this general, like, what is super important as we move forward of identifying X bars versus mu's and p hats versus p's, and also constantly, I can't remember when I made these old videos for 7 and 6, if I really drove home the idea of categorical versus quantitative variables, but if you constantly go back to what the variable is, that gives you a really good indication of whether we're in part 6 or part 7. Obviously, I can use keywords also to let you know if we're in part 6 or part 7. The 2 most obvious keywords being proportions and means. Proportions being part 6, means being part 7. But you can also see anytime we're given percents, we're dealing with summarizing a categorical, so we're in proportions land. And of course, we know that the word average is synonymous with mean. So either one of those can give you the right idea.